Okay, so in this question, we are given that water flows into the conical tank at the rate of 10 feet cube per minute, and the radius at the top of the cone is 14 feet, and the height of the conical tank is 21 feet. And we have to determine the rate at which the depth of the water is changing when the height is 12 feet. So let's see how to determine this rate of change of height. So this basically represents the rate of change of depth of the water. Okay, so first I have drawn the cross section of this conical tank. Here I show this cross section. We can see that we have two triangles. Maybe I can mark this as OAB is the larger triangle, and this is CDB is another smaller triangle. So we have to find a relation between the radius and height so that we can determine this rate dH over dt. So, as we can see here, these two triangles are similar according to the AA similarity, that is angle similarity. As you can see that this angle and this angle are right angles, and also this vertex angle is the common for both triangles. So, based on the angle similarity, we see that these two triangles are similar, and this means the corresponding sides are proportional. So I can write down this OA divided by CD, and this equals OB divided by CB. Let's put in the values. OA equals 14, which is the radius at the top of the tank, divided by CD is the radius at any point, and this equals OB, which is the height of the tank, which is given as 21 feet. So I put this as 21 divided by CB, which is the height at any point. We represent this as H. So we can now find the relation between R and H. So I'm going to do the cross multiply like this. So we will have 21 times of R, which is 21R, and this equals 14 times of H is 14H. I'm going to solve for R from this equation. So R equals 14H divided by 21. We can reduce this to simple form. That is, this is 2 sevenths and this is 3 sevenths. So it's basically reduces to 2h over 3. So we now found the relation between r and h, that is r equals 2h over 3. This is an important relation which we will utilize while finding the dH over dt. Now I'm going to write down the volume equation. The volume of the conical tank is given by 1/3 pi r squared h. Since we have already found the radius, we can substitute the radius into this equation, and so that we can have this equation in just one variable. So that's basically the purpose of finding the radius or the relation between the radius and height. So I'm going to rewrite this equation by substituting the radius, that is 1/3 pi. Radius is 2h over 3, and this is quantity squared times h. So let's simplify the right side expression. We have volume, that is V, equals 1/3 pi. The square of 2h over 3 is, we have to take the square of the numerator, that is 2 square is 4, and h square is h square over 3 square in the denominator, which is 9, and this multiplied with h. We can further simplify this by combining the constants and combining the variables. So the constant is, we have pi times of 4 is 4 pi, and divided by 3 times of 9 is 27, and h square times h is h cube. So this is the volume equation, which means we can now go ahead and find its derivative to determine the dH over dt. Now I'm going to find the derivative on both sides with respect to time. So derivative of v with respect to time is dv over dt, and this equals, we have a constant 4 pi over 27, so this remains same, and we just have to find the derivative of h cube with respect to time. So we can apply the power rule first, that is it becomes 3h square. That is, if we find the derivative of h cube, we put the 3 in front and reduce the power by 1. That is, 3 minus 1 is 2. So therefore it becomes 3h squared. And then we have to apply the chain rule to find the derivative of h with respect to time, which we now write down this as dh over dt. So now we have all the values which we can substitute here and determine this quantity, that is dh over dt. So I'm going to plug in the values which is given in this question, that is dv over dt equals 10. So let me put dv over dt equals 10. So 10 equals, we have 4 pi. In fact, we can reduce this. We have 27. We can see that it goes 9 times. So it is 4 pi over 9 times h square. We know that value of h is given as 12 feet. So I'm going to plug in 12 for h. So it becomes 12 square times dh over dt. And this means we can now solve for dh over dt. So let me multiply both sides by 9 and divide by this numerator expression, that is 4 pi times of 12 square. So this is 4 pi times of 12 square, and this equals dh over dt. Let's simplify this further. So let's rearrange and write down this as dh over dt, and this equals 10 times 9 is 90 over 4 pi times 12 square is 144. And this is approximately equivalent to 0.0497, and this is approximated to 4 decimal places. When we put this complete numerical expression into the calculator, we get this value. And we also put this unit, that is feet per minute. So we see that the depth of the water is increasing at a rate of, depth of water is increasing at 0.0497 feet per minute.